Okay, the next blockchain I really want to talk about is the Steem blockchain. Um, Mostly because I'm not that. I'll be honest, I'm not that familiar with the BitShares platform. I haven't used it at all. Steem had kind of come about right around the same time I was learning about blockchains, learning about Bitcoin. So I knew about the UTXO model, and when I saw that a social media platform could be built on top of the blockchain, I was like kind of in disbelief a little bit, because you think about how much data you'd have to store in blocks to pull something like that off. It seems like insurmountable. So it seemed like magic to me at the time. So I joined the platform, of course. Mostly with most of this crypto stuff, like I investigate platforms out of curiosity more than anything else, like having skin in the game, right? I want if something seems like magic, I feel like the more I use it, the more I'll be more apt to like unravel the magic and figure out how it works. It's part of the reason why I'm doing this course. I don't necessarily think that I know more about blockchain. In fact, like many people know way more about it than I do, but just like forcing myself to get on a video and talk about this stuff is forcing me to deep dive on topics that I never even had considered, right? To be a smart contract developer, you don't necessarily need to know how Ethereum handles state, really, to be honest. But I just did a video on it, mostly because I started talking. I did a couple takes and I realized, like, I don't really know how this works, so let me go investigate this and figure it out. So I kind of did the same thing here with Steemit. What I find interesting about the Steem blockchain is how many of the techniques that Dan came up with while developing the Steem blockchain, like handling the same constraints he handled building a social media platform on the blockchain, he's kind of applied them to the EOS blockchain as well, or like he's iterated on it at least. Like he's learned a lot of valuable lessons, and he's been able to apply them here as well. And then some, right? He's always, building the next thing. He's always iterating on his innovations, which I really like. But one of the things while I was reading the Steem Steem white paper was this thing right here. These 5 key concepts, because I think they actually apply very nicely to the EOS blockchain. When we talked about the Ethereum blockchain, part of the problem was it's essentially single-threaded, right? That Patricia tree we're looking at and the state transition functions, like they're not parallelizable. The Ethereum Foundation currently, at the time I'm recording these videos, is working on sharding. They're wanting to make things parallelizable. They're also working on Plasma to have different blockchains to kind of like move some of the transactions away from the main Ethereum blockchain. But as it stands today, it's single-threaded. So some of the computations that Dan had to be able to achieve with the Steem blockchain, he really had to think deeply about the architecture, and I think these key points also kind of got applied to EOS as well. The first one being, keep everything in memory. You see that with the you will shortly when we start diving into EOS development. We have these tables, and those are all stored in RAM, and people pay EOS tokens in order to store things in RAM, and when you delete things, you get your tokens back, and the RAM gets reallocated back to the block producers. So this number one point is, I think very, very important, keeping everything in memory. The second one is keep the core business logic in a single thread. Ethereum's doing something very, very similar to this, but they're not doing part 3, which is keep cryptographic operations out of the core business logic. It's the Ethereum blockchain is single-threaded in that it takes the core business logic, it applies that in the same thread, but it also does the crypto operations in the same thread as well. And from what I've been reading in the EOS Telegram, is like that's the biggest bottleneck to their throughput currently is these crypto operations. They're very hard to do. They're hard on a CPU. Doing a lot of them takes up a lot of CPU clock cycles. Part of the reason you have to keep the core business logic in a single thread is some of these transactions have to happen sequentially. For example, when we talked about the Ethereum state transition function, like, you can't take money away from Alice before taking money away from Bob in some cases, right? Because Bob might not have enough ether until Alice pays Bob, but those can happen in the same block, right? So certain things have to happen sequentially, certain things can happen in parallel, and that's one thing the EOS architecture has done very well, I think, is it's kind of forced smart contract developers to define things in such a way that they can be parallelized. Like certain things can be parallelized, certain things cannot be parallelized, but you must define those when you're writing the smart contract, which is a very good thing in my opinion. The last thing here is they divided validation into state dependent and state independent checks. I'm not terribly familiar with this, but I know the EOS one aspect that they had recently announced prior to me making this video was context-free actions. So again, I think it's a matter of detecting or at least forcing the smart contract developer to define what's state dependent and what's state independent, because again, this allows for parallelization, which is very helpful in trying to speed up blockchain and make it more efficient. Essentially, again, that's the biggest drawback currently with Ethereum is it's single threaded, and there's really no way of fixing that. Again, they're trying to do that, but who knows.